Hello, Dr. D. My name is Daniel Middlebrooks, and in this video, I'll be explaining the X-ray circuit and the X-ray tube. Now, at the beginning, before power is turned on, outside of the building, there will be 220 volts. Once the power is turned on, it goes into the building and through the main switch, where there will be three lines. Line number 1, line number 2, and line number 3 that goes through the filament side. Now, once power is turned on, that 220 volts will become 110 volts and 60 hertz that will be going through the circuit. Line number 1 and 2 will meet up at the auto transformer. This is where the technologist will select the KVP. We'll say we'll have a KVP of, kilo voltage of 120. The kilovolt meter will read that, and the arrow will go to the 120 setting, and we'll call that induction number 1 right here. And there will be 5 points of induction within the whole circuit itself. Well, actually 6 points of induction, the 6th one being inside the X-ray tube. We'll get to that later. So induction number 1, and then we have after that, we'll go to line number 3. It's all basically happens at once, but at line number 3, through the filament side, you'll go to the variable resistor, and that's where the technologist will select the MA. Say we have a MA or milliamperage of 25. So the filament ammeter will read the MA of 25, and the MA selector will basically pick that up, and we'll call that induction number 2. After that, we'll go over to the exposure switch and the timer. And the technologist will select a time, we'll say 3 seconds, and the timer will affect the exposure switch after we send the time, and the exposure switch will act like a drawbridge, and once the exposure switch closes, that will close the circuit to make it work, and it will close for exactly however much time we set, say 3 seconds. And after exactly 3 seconds, it will open back up to stop the loop. After that happens, we'll go to the step up transformer. At the step up transformer, basically works as there's less coils on this side, the low voltage primary circuit side, and more coils on the high voltage secondary circuit side. And that's how it steps up the voltage from 110 volts to 10,000 volts. Now the MA meter will basically read the voltage once it goes through the step-up transformer, and if it's less than 10,000 volts, then it will stay on this side. If it's more than 10,000 volts, it will be stored in the capacitor, and the capacitor at the ground level right here, it'll work with a falling load generator. And the falling load generator will spurt out 10,000 volts each time. And once it's done with that, then it'll go to the 4-diode rectifier. Now the 4-diode rectifier is what changes the alternating current to a pulsating direct current. And it will have 2 paths that will be going back and forth through the rectifier, back and forth. Path number 1 starts up here, goes here and up this way, and through the X-ray tube, over through the secondary diode here, down and end right here. The second path that will be going, after the first path and back and forth, it will start here, go through here, through this diode, then through the X-ray tube, then the second diode here, and end here. And if I haven't already mentioned it, the step-up transformer will be induction number 3. Now we'll move to the filament side and the step-down transformer. A step-down transformer works pretty much the opposite of the step-up transformer, and there's more coils on this side and less coils on this side. And on this side of the filament, it will have, I believe, 3 to 5 amperes and 5 to 6 volts. And that will go to the X-ray tube. And the 5 points of induction is here, 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 and here. 1, 2, 3, 4, 5. Now move on to the X-ray tube for the second portion of this video. This is the X-ray tube itself within the X-ray circuit. Now the 10,000 volts that I was speaking about before will go through the stator electromagnets. The stator electromagnets, through the use of the induction motor and with the help of the armature and the bearings right here, will move the rotor. This is the rotor right here. It'll move that, which then moves the anode, as the neck and base, the molybdenum neck and base of the anode is attached to the rotating portion. So that spins the anode, and the anode is made of tungsten, and we use tungsten for the anode because of its high atomic number and high melting point. Real quick, this is the anode side and this is the cathode side. Now on the cathode side, we have the filament circuit, which goes through this portion, and the filament holds the focusing cup, and the focusing cup is responsible for the thermionic cloud. Thermionic cloud of electrons is shot out through the filament, through the focusing cup, to the target anode. At the target anode, that's where all the electrons basically turn into photons, which is essentially the X-ray beam. And when it becomes the X-ray beam, not all the photons get shot through the tube. Some of them get, as this happens, get dispersed throughout the glass envelope. All of this is encased in a glass envelope, which is essentially the vacuum, which is necessary for the X-ray tube. So that concludes, oh, and the 6th point of induction, real quick, is at the stator electromagnets. This concludes my video. Thank you.